Hello everyone and welcome to Mathematics School U. In this video, I am going to share my approach of handling this question through complex number. Well, I call this question as an all-in-one question of complex number because I'll be using all important concepts of the chapter for solving this, like rotation of a vector, nth root of unity, vectorial representation of a vector. So let us start the video by reading the question and let us solve this question. The question says, the figure shows a regular heptagon with side length of 1. Determine the indicated length d and express your answer in the simplified radical form. So the question is very simple, like 2-line ka question hai. Now I just need to see how we are going to handle it. Now first of all, you can see the figure that they have provided us in the question. It clearly shows that it is a parallelogram that we have, right? But what is the use of parallelogram? That also we will see. Abhi to hame sirf itna pata hai ki each side length is actually equals to 1, right? And this length is also 1. This is d which I need to evaluate. How we are going to solve the question using complex numbers? Now let us see. So मैं क्या करने जा रही हूँ? First of all, I'm just going to keep this whole figure. I'm going to keep this whole figure at origin. Ab origin means normally whenever we come across a regular polygon, we keep the center of the polygon at origin. And after that, it becomes easier for us to identify the vertices. Why? Because they are equally spaced. Regular polygon की हम बात करें, equally spaced होता है तो easily हम उसके सारे vertices with the help of complex numbers लिख सकते हैं. But यहाँ पे दिक्कत क्या है कि if you take the center as origin, then you will have to go additional calculation you will have to do to identify the radius of the corresponding circle, right? I don't want to increase my calculation part for that. That is why I'm not taking origin at the center of this polygon. Instead, what I'm going to do, I'll take origin at any one of the vertex. So I selected this vertex at origin and I'm just naming this vertex at A. ठीक है, OA को हमने ले लिया along x-axis, where O is at origin means you can write down the coordinates of point O as 0, 0. And A को I'm going to write as -1, 0. Well, I'm interested in getting the position vector for this point P. ठीक है, हमें P का position vector चाहिए या फिर ये कह दीजिए कि हमें point P के corresponding complex number find करना है. One thing is clear after taking the origin and the point A like this. And what is clear? The point P is going to have the coordinates as -1/2, right? That is going to be -1/2. You're just dropping the perpendicular. So -1/2 and after that D. These are going to be the coordinates of the point P, or I can say that point P is nothing but -1/2 plus D iota. This is how I can express the point P. But is there any other way to express the same point P? So yes, we do have another way to express this point P, and that I'm going to do with the help of vectorial representation. What I'm going to do is, I will write that ये जो OP vector नजर आ रहा है ना, that is going to be equals to, अभी हम इसे O, A, B, C, D, E and F करके लिख लेते हैं. तो I can write that OP vector will be equals to OF vector plus FE vector plus EP vector. Right? I can write it like this. Okay, this is going to be equals to OF plus FE plus EP vector. That is going to give me the OP vector. Well, OP vector I already have. I calculated it through the point A and O. हमने OA की help से तो point P के coordinates लिख ही लिए हैं. Alternatively, I am going for the point P with the help of this vectorial representation of vector concept. ठीक है, वेक्टोरियल रिप्रेजेंटेशन ऑफ अ कॉम्प्लेक्स नंबर वाला कॉन्सेप्ट हम लोग यहाँ पर यूज करेंगे. अब उसके लिए आपको क्या क्या चाहिए? फर्स्ट ऑफ ऑल यू नीड द OF वेक्टर. OF वेक्टर सिंपली आई कैन से दैट OF वेक्टर स्टार्ट्स फ्रॉम ओरिजिन. सो OF का मैग्नीट्यूड इज 1 and regarding the angle that it makes with the positive direction of x-axis, you can clearly see that this angle will be equals to 2π/7. Right? Why? Because it is a regular heptagon. So जब आप exterior angle निकालोगे, it is going to become 2π/7. That means यहाँ पे भी जो angle ये आ रहा है ना, this is 2π/7. ये 2π/7 ही आ रहा होगा. Again, I can say that this angle is going to be 2π/7. And because you have rotated this one, तो ये angle भी हमारे पास कितना होगा? This angle and this angle are similar. So this angle, जो भी हमारे पास एंगल बन रहा था उसके अकॉर्डिंग हम लोग अगर बात करते हैं तो दिस एंगल अगेन टर्न्स आउट टू बी कितना आ जाता है? 2π/7. ठीक है, ये भी 2π/7 है। कैसे हमने आइडेंटिफाई किया? एक्चुअली 2π/7 अगर ये एंगल है तो हमारे पास दिस एंगल बिकम्स 5π/7, राइट? पैरेललोग्राम है तो दिस इज ऑल्सो 5π/7 and now the remaining angle 4π/7 are to be divided equally into these two angles. तो इसीलिए each angle 2π/7 के बराबर तैयार हो जाता है। ठीक है, तो हमने ये सारे एंगल्स लिख लिए हैं जिनकी जरूरत मुझे आगे पढ़ने वाली है टू राइट डाउन द कॉरेस्पॉन्डिंग कॉम्प्लेक्स नंबर। Well, I started with the OF vector. So what is OF vector? OF vector is 1 into e raised to the power iota 2π/7. And when you look at e power iota 2π/7, it seems that it is nothing but a seventh root of unity, right? What are the seventh roots of unity? E power iota 2n π/7. ये होते हैं सेवेंथ रूट ऑफ यूनिटी, जहां n की वैल्यू 0, 1, 2 से लेकर आप कहां तक जाते हो? 6 तक वेरी कराते हो, राइट? सो ये हमारे सेवेंथ रूट्स ऑफ यूनिटी है, एंड OF वेक्टर आई एम गेटिंग एज अ seventh root of unity. Well, I am right now more interested in calculating the FE vector. So I am concentrating on FE vector now. FE vector is obtained by rotating OF vector in the anti-clockwise sense. See, OF vector ये रहा, you are rotating it in the anti-clockwise sense by an angle of 2π/7. Yani you can write it as OF vector multiplied by e power iota 2π/7. which ultimately gives me e power iota 4π/7 as the FE vector, right? Similarly, now I'm going for EP vector. I want EP vector, so which is obtained by rotating FE vector in the anti-clockwise sense by an angle of 4π/7. आप देख लीजिए, जो टोटल रोटेशन हमारे पास यहाँ पे हो रहा है ना अब FE vector का, that is 2π/7, 2π/7. Total 4π/7 से you are rotating it, correct? 4π/7 से रोटेट किया, यानी ultimately I can write it as e raised to the power iota 8π/7. So, well, these are the three vectors which will help me in identifying the OP vector. So, I'm going to write now that OP vector is the sum of these three: e power iota 2π/7, e power iota 4π/7, and plus e power iota 8π/7. All these three terms that we have written here are nothing but the seventh root of unity, correct? Now, if these are seventh root of unity, then let us see what all 7 roots do we have for unity. One is 1, the other one is e power iota 2π/7. The next one is e power iota 4π/7. Then we have e power iota 6π/7, e power iota 8π/7, e power iota 10π/7, and then I'm going to write e power iota 12π/7. So look at these 7 roots that we have, that we are getting here. The 7 roots that we are getting, out of these 7, the one which are already available in the question are 1, 2, and 3, correct? These are the 3 roots that we are using here in the OP vector. So OP vector हमने दो तरीके से evaluate किया है. I'm definitely going to equate it, but before that I started concentrating on the values that I got here, and I came to know that they are nothing but the 7th roots of unity. Out of 7, 1 root is 1. The remaining 6 roots में 3 roots are like this, and the remaining 3 are definitely going to be their conjugates, right? आप e power iota 6π/7 को alternatively क्या लिख सकते हो? You can write it as e power minus iota 8π/7, right? These two are conjugate of each other. Just check these two. They are conjugate of each other. The product of these two turns out to be 1. Similarly, when you're talking about e power iota 10π/7, you can replace it with e power minus iota 4π/7. Correct? I'm writing down the conjugate of e power iota 4π/7, which will be same as this thing. And similarly, this last angle will be e power minus iota 2π/7. So basically, I can say that out of 7, 1 root 1 को अगर मैं हटा देती हूँ, तो remaining 6 में से 3 roots are already there, and the remaining 3 roots are nothing but the conjugate of these 3. But why we are considering this, and what and how we are going to utilize it for solving the question? So let me tell you. What I'm going to do in my next step is I'm going to consider function f of x. Okay, that is going to be x minus e power iota 2π/7. X minus e power iota 4π/7, and then we have the third factor is x minus e power iota 8π/7. So basically क्या करना है, या तो you just go and calculate this value by converting it into cos plus iota sign, ठीक है, एक तरीका ये हो सकता है because you just have to go and equate it to minus half plus d iota. D means the imaginary part of this expression. So this is also OP vector, and alternatively we calculated OP vector like this. So when you compare it, you can say that the imaginary part of this OP vector is going to give me the answer. अब imaginary part of OP vector is going to give me the answer means क्या करेंगे, या तो आप इसे sin cos में convert करके sin 2 pi by 7, sin 4 pi by 7 and sin 8 pi by 7, you get the sum of that thing and you will be getting your answer. ठीक है, या तो आप उस तरीके से प्रोसीड करो और नहीं तो ऑल्टरनेटिवली आई एम गिविंग यू वन मोर अप्रोच. सो लेट मी जस्ट टेल यू कि वन मेथड दैट आई एम डिस्कसिंग हियर इज, व्हिच आई विल लीव फॉर द कैलकुलेशन पार्ट फॉर यू पीपल, व्हिच इज d is actually equals to the imaginary part of e power iota 2 pi by 7 plus e power iota 4 pi by 7 plus e power iota 8 pi by 7, which actually gives me the value. कितना आंसर आ रहा है? You can write it as sin 2 pi by 7, क्योंकि imaginary part में वही हमें मिलेगा, sin 4 pi by 7 plus sin 8 pi by 7, right? This is how we can write it, correct? So ये आपके पास d की वैल्यू. अब इस d की वैल्यू को evaluate करने के लिए either you proceed with the series of the sign. आप sin 8 pi by 7 को alternatively sin 6 pi by 7 लिखकर भी proceed कर सकते हो, and then you have to get your answer. ठीक है, सो या तो आप इस तरह से प्रोसीड करेंगे और नहीं तो अल्टरनेटिव अप्रोच मैं आपको यहाँ पे अभी बताने वाली हूँ. तो बोथ मेथड्स आर फाइन. दिस क्वेश्चन यूजुअली वी सॉल्व फॉर we can say that in trigonometry we usually solve this question, and that also we solve with the help of complex numbers only. So either you proceed using this method and get your answer, or you can do a little bit of manipulation to get your answer. अभी little bit of manipulation का क्या मतलब है वो मैं यहाँ पे शेयर करती हूँ कि मैंने क्या किया, मैंने एक फंक्शन ही assume कर लिया. Function f of x is this, and now I know that OP vector जो मुझे मिलेगा, OP vector is going to be equals to x square का coefficient, right? ठीक है. Now what I'm going to do is I'm going to consider another function f of x का conjugate. What is going to be f of x का conjugate? It will be x minus e power minus iota 2 pi by 7, x minus e power minus iota 4 pi by 7, and then we have x minus e power minus iota 8 pi by 7, correct? And when you multiply these two together, you will come to know that I am getting all the 6 factors of the 7th root of unity, and x minus 1 is missing. Total 7 factors होंगे, यानी आप इसे क्या लिख सकते हो? Basically, I am getting all the 7th roots of unity में से आपके पास 6 roots यहाँ पे already available हैं. ठीक है, all these 6 factors का product I am writing here. So it will become e power minus iota 8 pi by 7 like this. Now, if I just multiply and divide it with x minus 1, then you will come to know that numerator is nothing but a polynomial, which is x power 7 minus 1, right? I can write the numerator like this. Why? Because you are considering the 7th roots of unity. Now, all 7th roots of unity are present here, and I have written it in the factor form. तो जब आप उन सब का प्रोडक्ट लोगे तो अल्टीमेटली आपको मिलेगा क्या? जो पॉलिनोमियल हमें मिलता है that is x power 7 minus 1. But now because x power 7 minus 1 upon x minus 1 I have written here, so I can say that this will reduce to a gp 1 plus x squared and so on till x power 6. So ये हमारे पास fx into fx bar तैयार हो गया, and fx into fx bar के तैयार होने का ये मतलब है कि now I am going to proceed with some more calculation part. Comfortable calculation part है, but it will help me in getting the value of d. कैसे मिलेगी d की वैल्यू? तो उसके लिए आगे बढ़ते हैं और इसे होल्ड करके रखते हैं. ठीक है, ये हमारे पास आ गया f of x into f of x का conjugate. इसे मैंने मार्क कर लिया 1. ठीक है, now let us proceed with f of x. What exactly f of x we are getting? We are getting it as x cube minus sum of the roots, which was actually minus 1 by 2 plus d iota into x square. Then we have plus the coefficient of x. What is going to be the coefficient of x? Just look at this equation and see what will be the coefficient of x in f of x. So let me show it to you what is going to be the coefficient of x. Coefficient of x के लिए एक तो आएगा इन दोनों का product, यानी it will become e power iota 6 pi by 7 plus the product of these two, which will give me e power iota 10 pi by 7 And then I will have the product of these two, which will be e power iota 12 pi by 7. Correct? But e power iota 6 pi by 7, अभी हमने देखा कि this is nothing but, ये हमारे पास क्या है? This is equals to e power minus iota 8 pi by 7 है. Then we have the second term is e power minus iota 4 pi by 7. And this is equals to how much? We can write it as e power minus iota 2 pi by 7. So the sum of these three terms is equals to conjugate of the sum of OP vector. Conjugate of this OP vector. Just look at this one. The sum of these three is nothing but the conjugate of this. And what is the conjugate of OP vector? Conjugate of OP vector means minus half plus d iota ka conjugate. So I'm going to write down the conjugate of this one as the coefficient of x over here. So minus d iota x. And then coming to the coefficient, or you can say the constant term over here. The constant term is nothing but the product of roots. So यहाँ पे 3 roots का product जब आप देखते हो, तो it turns out to be e raised to the power iota 4 plus 2 plus 8. That means 14 pi divided by 7. So ultimately वो 1 में convert हो जाता है. So I'm going to write it as minus 1. यानी f of x into f of x bar मुझे यहाँ पे मिल रहा है, and f of x I have written it like this. यानी ये जो दो equations है ना, now these two equations are definitely going to help me in getting the value of d very comfortably. कैसे करेंगे आप solve? आपको d चाहिए, तो you just evaluate here f of 1. ठीक है, आप f of 1 को evaluate करो. f of 1 को evaluate करेंगे तो what we are going to get? On the right hand side it is 1, then I have plus 1 by 2 minus d iota. Then I have minus 1 by 2 minus d iota and then minus 1. And you can say that 1 will get cancelled. Half will also get cancelled. Correct? Half also we are getting as cancelled. So from here I am getting this one as minus 2d iota. Implies modulus of f of 1 will help me in getting the value of d. This we are getting as 2d. Correct? Modulus of f of 1 जो आ रहा है वो 2d के बराबर आ रहा है. But can you get f of 1 through any other approach? Yes, with the help of this equation. If you are taking x is equals to 1 both the sides, so I'm just keeping here x equals to 1, which will give me f1 into f1 bar, which actually shows that it is f of 1 ke modulus ka whole square. Keeping x equals to 1 on the other side gives me the sum as 7. So yes, I do have the value of f of 1 from this first equation. And I'm going to use it over here. यानी क्या करेंगे? Modulus f of 1 का whole square 7 है. यानी आपके पास 2d की value आ जाएगी root 7. And if 2d is equals to root 7, then d is equals to root 7 divided by 2. So here is the answer that we are getting for the question. So ये जो end का approach है ना, this is slightly different from what usually we use. यानी होता क्या है इस step के बाद? First of all, तो writing these steps are also very important. कि आप क्या कर रहे हो? Question को वापस से देखो. आपने पहले तो question में कहीं पर भी complex number नहीं दिया था. तो we actually interpreted it कि okay, we will solve it using the complex number approach. Then what we have done is we have written OP vector in two ways. One was directly minus half plus d iota. The other way that we used here was the sum of the vectors. हमने vectorial representation की help यहाँ पे ली complex numbers में, and then we wrote the OP vector alternatively. How did we write these OF and FE and EF EP vector? उसके लिए हम rotation vector को use कर रहे हैं. तो ये जो सारे steps है ना, these steps are also very beautiful and important steps that we are using for solving the question. Well, after writing OP vector, as I told you, because you just need to get the value of d, you can definitely proceed by writing that d is nothing but the imaginary part, that means equals to this one. Now this itself is a kind of standard question that we usually solve while preparing for J. So that's why I have just given you the hint to solve this question, and I have proceeded with a little different approach just to share this new approach with you all. So I hope you enjoyed this new approach of handling the question. So again, don't forget to hit the like button and share the content with your friends and fellow aspirants. See you in the next video. Till then, keep learning. Thank you for watching. Bye-bye for now.